firstly, the criteria of this is that the whole switched system should have a common layout function. And actually, it turns out in such a CCC framework, the quadratic terms, the unit layout function that we usually use will work. And it can be proved that a switch system can be actually stable. Yeah, if we can ensure that the vehicle movement, the individual vehicle in the platoon is stable by the controller parameter settings.
And I have another question. I mean, you mentioned for the new, for the no communication failures, and you mentioned that the performance is the best. However, like in the like in the cooperative control theory of the multi-agent systems, I mean, sometimes if you have more information, it does not mean your control performance is best. For instance, you may have more information, then like the information will be be redundant. So can you?
Yeah. So you answered your question, sir. Because if you have the information, the point that we are making is, if you have all the information, then you use the information that you need to. The other information you just ignore. The point we are saying is the information is available. That's the point we are trying to emphasize. Versus the case where failures occur and that information is not available. That's all.
So just ask, like in reality, when my vehicle receive a message, like how do I know it's the second preceding vehicle sends a message to me, not the first preceding?
So one of the things I thought I mentioned at the very beginning, this is a connected autonomous vehicle. Okay, so you can sense. So each of those can be sensed. So if this is not a human making decisions. I don't know if that's what you were trying to imply.
So it's like the whole platoon knows their
yes, there's a whole platoon of CAVs here in this case. It's a pure CAV platoon.
I have a question on the computation cost. For me, I think the computation cost will increase when you have a large size platoon, right?
It will increase. Size anytime it has to increase, right?
Yeah. So if the large size platoon control problem cause problem to you, so have you considered to disengage your long size platoons, break down to them to some small size platoons to solve that problem? And I have a question similar to the previous questions. So we know the platoon with full communication is the best. But what if we have another approach to break down those long platoons into smaller platoons, and they can also achieve a satisfying result? So we can kind of get around those high computational cost, or just try to find an optimal solution for that complex problem.
Okay. So I'll answer this first at a much higher level. Because when we are now starting out in the era of connected autonomous vehicles, okay? So if you're saying that we'll have a platoon size of 200 vehicles, that's not going to happen, right? And the most people are talking about, of course, is that there'll be limitations to the platoon size, okay? And what we have done here is to take a reasonable size at the upper end for what the platoon will look like in terms of the number of vehicles. Because if you go longer, as I mentioned earlier, you'll have problems in terms of having vehicles go to their destinations at the network level. There are different objectives than what are there at the link level, right? So that's the point that we were looking at. It's not like we were looking at, okay, should I start with 100 vehicles? My point is, it doesn't make sense to go with 100 vehicles. So what we wanted to see is what happens if the upper limit is in a reasonable range. That's why we went 11 to 16 or whatever that we did, or 12 to 16. We did that. Okay. So in that sense, if you bring in realism, going forward in terms of policies related to the platoon maximum plus platoon size allowable, I don't think we'll have this issue. Okay. But you're right. If platoon size increases, you will have more cost. Okay. We actually debated that at the very beginning. So the question is a valid question, but then the point is, what would be an acceptable size for a platoon going forward. So if it is in the order of 100 vehicles or something, then yes, what you're saying is important.
Just follow the question. So what's the, right now, in practical use, what's the number of people in a typical platoon in an operation vehicle?
You mean in CAV or any?
Uh,
Because in CAVs don't exist, I mean, so we don't have that right now.
oh, okay.
Yeah. So, but these are going forward into the future. But you're seeing platoons of vehicles right now where groups, which feel that it's dependent on the behavior. The human-driven vehicles, they all belong to a category that they're very aggressive, or they form that platoon. The slower ones are theirs, right? I mean,
So is that operating now as platoon? What's the typical number of vehicle in the current operation in the field now?
that there's no typical number because it depends on the conditions. That's what I'm trying to say.
I see.
So for example, what I'm saying is, if there are slow-moving vehicles and then there are other vehicles that are saying, no, we need to go faster, at some point there'll be a group of them doing that, but then they're also capped at the point where they feel they don't want to exceed the speed limit by too much. Okay, that's how you have this, platoons forming. So they all feel, belonging to people that would be behaving homogeneously in certain ways in terms of what they're comfortable with in terms of that. And beyond that, it really depends on whether it's a platoon or not, depends on whether they hit other bottlenecks and so on. So that's a different context. I'm not talking about that.
Same question.
Yeah, so on the plots on the previous couple slides, 28 and 29, I think. So these are the follower vehicles. What's the leading vehicle doing in this? Is that right?
Oh, the leading vehicle is getting its, I think I mentioned earlier, its data is coming from the NGSIM data.
Oh, okay. Yeah, that is just, so it's just following that.
Exactly. That's why at the very beginning I mentioned, remember we talked about a CAV context here. So in a CAV context too, because you have lane changing and other things, the leading vehicle will also have dynamics that have to be accounted for.
Yeah, okay. And so I presume in these simulations you're not concerned about collisions or anything like this?
Collisions of...
Between the vehicles themselves, literally.
Collisions between, you mean the following vehicles?
Yeah.
Oh.
If the spacing errors get too small, right?
Right.
That's not showing, that's not.
No. So that's not showing good, right? I mean, so we don't have any.
We didn't consider the
Right.
safety sets constraints in this.
Right.
Yeah.
Okay, if without any further question, please join me. Thank you very much. Okay, so we'll stop here.